Hello and welcome. Now today we have an extra specially good treat. We are going to use the Vernier Go Direct Structures and Materials Tester. This is one of my favorite probes. It will allow us to measure the force required to break bridges. In this case, the bridges that we build ourselves. I have three examples. One is a single strut bridge, the other is a double strut bridge, and then the third one is a bridge I've built myself. To talk about the materials tester itself, there are several different parts. There are plates up the top that you can adjust so you can move them in and out for smaller things. This over here is the block with the force sensor, which will allow you to measure the force required to destroy something. This wheel will be turned and measured in order to know the displacement required. So, before we get started, there are two things I will mention. Number one, the structures and materials tester only goes up to 2,000 newtons. If you go beyond that, then you are looking for something that is going to possibly hurt the people around it as it breaks and the energy gets released. The other thing is, you need to use proper safety glasses, safety first. Let's get started. The first thing I'm going to do is connect it to the computer. Now, as I've turned it on, the red light's flashing, and if we go to the computer, we can go to sensor data collection, connect the structures and materials tester. The two channels I do want to use are force and displacement, so I'll just go done. We are now ready to start testing things. So the first thing I'm going to test is this single bar strut. I'm going to do that using this initial tackle and going onto this eye bolt here. So let's set this up. I'm going to put this through the middle. I'll pop my bridge there, and then I'll use the quick link to attach to the eye bolt here. It is important to make sure that you do tighten your quick link all the way, otherwise you're going to stretch it depending on the forces required. I'm going to move the platform down lower just so it starts to touch before we add on any force. It's now touching. Now that we've done that, I'll go to the software again. In the software, I'm going to go to force and zero it. I'll go to the displacement and zero it as well. Then we'll start collecting data. You can see the force increasing, the displacement increasing. You can see the flexing that's starting to happen, and we could look at flex if we wanted to, but I want destruction. Oh. Now that the crack has happened, we're actually at a point where we are ready to test the next thing. First thing you need to do is release the force on this. So I'll release the force, and then we'll be back momentarily with this one set up. This is the double span. Okay, we're now back. So over here, I've actually put the double span, and we'll test this. I've lowered this to the point where it is touching, and so we can do the force. Now let's go back to the software. On the software, I will zero the force, zero the displacement, and then go collect. let's apply force. What I can see is one side of the span has actually broken. You can see what the maximum force was and the displacement at that time. What I can do now is turn on the force of the first one, the displacement of the first one as well, and then we can compare them. So the level of force required in our first one was 139 newtons. The second one was 260. Now these results are quite interesting because it shows that we've doubled the number of struts, so we've doubled the force required to break it. Now that we have that in plan, we'll now go to our final one, the bridge. Now, because the bridge itself is a lot taller, we're going to be using one of the rods in order to pull it down. In order to attach the rod, just like with the tackle, I just need to screw it in here. Now it's screwed in, I can pop my bridge on top. And then I'm going to use one of the plates. So I'll pop the plate on top. And then I'll screw it down. Okay, now that I've actually screwed it down, it's now ready. I'll go back to the software, hit collect, and now we'll apply force to the bridge. I'll stop it there. We've had a break on one of the struts. It was a little bit earlier than I hoped, but let's see how the forces compared. So here we have the data of that last one. For comparison, I'll turn on the other two trials that we've run. You can see it managed to take the force slightly less than the force bends just by itself. Bridge building is done universally in a STEM activity. This way, it'll actually give you a greater ability to gauge properly how well your structure is being designed. For this one, my bridge was slightly off. However, it did do better than the single span itself. If you have any further questions, please feel free to contact me on the following email address.